What's up? Welcome to the Poppy Seed channel. I'm recording today from the car, and if you want to know how EigenLayer AVS works, well, continue watching. So what is EigenLayer? So EigenLayer introduces a concept called Ethereum restaking, and let's look into what that really means. So first off, we have to understand how staking actually looks like. So we have an operator, well, let's call him validator for now, that stakes Ethereum in basically their Ether for a chance to validate Ethereum network. And in exchange for that, they get some rewards directly back, right? That's quite simple enough. So with what we do with EigenLayer restaking, we take those ETH rewards, we reroute them to a different contract. And basically in this contract, we are securing an additional module. This module can be, for example, bridging, it can be any off-chain computation, oracles, something like that, something that requires some off-chain computation, right? And this additional security layer is basically getting all of its security from the main Ethereum network. So when we are basically rerouting those rewards, we are not securing only with the pool of our own money, but with the pool of the staked Ethereum's money that we have staked inside. So in addition to this, we then say, okay, for you, because you were acting as a validator in the Ethereum network and as an operator in securing our additional modules, you'll get some extra rewards and also extra Ethereum basically rewards that you already get before. However, if you'll be a bad actor, well, you will be having also extra slashing penalties if you are a bad actor, right? So you won't get only penalties on securing your Ethereum, but also if you'll be a bad actor here, you'll get penalty on the Ethereum that you secured. So this is one setup that you can do with setting up your AVS. A second option is basically you're a normal validator, you stake some ETH in the Ethereum network, and if you go through on, let's say, liquid staking platform like Lido, you get some liquid Ethereum back. Well, what you can do is either you or some different operator can take that liquid Ethereum and use that to secure an additional module. This option too is a bit less secure, but it's still quite a good alternative, right? And from securing this additional module, you can get some extra rewards. So if we go to setting up our first AVS, you can basically clone this GitHub repository, and let's set up our Hello World AVS. So what are we going to do here? So as you can see here, we have welcome to Hello World AVS, and there's a nice illustration here, what's going on. When I first seen this, I didn't quite understand what's going on, so I made a different representation of it. So let's see what's going on. Hopefully you can understand my writing. So here we are an AVS consumer. So this is the little guy who basically, I don't know, he wants to transfer its tokens from one chain to another chain. For this simple example, he just wants the operator to generate and sign a Hello World message. Or maybe he wants to do some verification on the Oracle side or something like that. This AVS consumer can be a like secondary contract or anything like that, right? In this very simple example, we just are an AVS consumer and we want some basically our operator to generate Hello World. So what we do is our contract that is living on our Ethereum network, we call this contract and say generate Hello World. So this contract submits an event, generate Hello World, and this operator picks this event up. So when it picks it up, it generates a message Hello World, and it signs it with its own signature. So you have a message plus a signature. And this contract, when it picks this up, it accepts or rejects it, and if everything was fine, it accepts it and emits an event that actually this has been done on the network. And we can verify that an operator actually generated Hello World message. So in this example, it's also you have a AVS consumer, Hello World was generated by a contract, so operator is here. Maybe these arrows are a bit confusing. An event is signed here, you say Hello World, operator, so message is generated Hello World, it's signed and sent, and if an operator finds out that the operator stake, so the staking pool, as we mentioned here before, if this is enough, So if staking rewards are enough, if they meet the needs of the operator, then the requirements are set, the event is accepted and emitted. Yeah, great. So as we established the basics, let's check our GitHub repository. So this is the Hello World AVS. As we are all familiar with, you do basically git clone this command, and of course it clones the GitHub repo and you cd into it. Now, what you'll have to do is open up Docker. So basically install Docker and open it up. So here basically we need it so it can construct images and containers. So what's next? Okay, let's have a quick look at our repo. What does it do? So here we have a simple README with the concepts that we already been talking about. And there's some quick startup guide on what we have to do. So if we go and move into our repo and we do yarn install, and we have already installed it. So next command is basically make start chain with contracts deployed. And this will build basically the contract, start an unveil chain, deploy the contracts to it, and leave the chain running in the current terminal. So it says that the requesting image platform Linux does not match the detected host. However, this shouldn't be the problem for our simple example. So it's advancing the chain and it says the current block number is 100. So this is currently running. So let's open up a new terminal now and we will start our operator. So this will compile the AVS software and start monitoring new tasks. So if we do make start operator, and let's basically check our code, what does it do? So how you can quickly check the code and understand what's going on. So you have the environmental variables, these are already partially populated. And if you check in the Docker file, very simple. The most important now, because we were all running the commands make file. So here you can check, so as before we were running make start chain with contracts deployed. So if you check where is this command has started. So make start chain with contracts deployed. Okay, this is this. So what does it do? It runs the shell script .sh as a shell script in the utils anvil start anvil chain with L and AVS deployed. Okay, so if we check the script here, we can basically see it runs a bunch of commands. It starts a parent path, and if we check here, it also starts source.utils.sh. Let's check what this does. So as we can here quickly see, it starts basically something that's got to do with the Docker. And if we check into the documentation, this will build the contract, start an Alvin shell, deploy the contracts to it, and leave the chain running in the current terminal. So that's what it does. So here you can see all the associated utils are here with the anvil, and here we have the state that is basically has been generated. Next, the key things are contracts and operator. Let's look into the contracts, how they look like. The main contracts, this is basically done with the Forge. Forge has Forge build, Forge test, and so on. When you will want to do any sort of compilation, use the command Forge build. So if you go to the source directory, and here is basically a mock ERC contracts. So if you remember this kind of diagram I was showing you before, we have basically an operator, and these are the ERC funds that we mock that are being currently secured. So these are these mock ERC20 tokens that are being secured. And if we go to the Hello World Service Manager, so it creates a new task, it responds to a task, and that's it. So if we go to our contract over here, it responds to a task and creates a new task. So that's fairly simple stuff that you can do. And if you want to build something on top of that, you can expand on these functions here. Next, if we check on the operator, what exactly does it do? We have a bunch of ABIs in the start, some environmental variables that are imported, like contract address, delegation manager address, stake registry address, and so on. So ABIs are here, all stored already for us. And then we have a few functions: sign and respond to task, register operator, and monitor new tasks. So if you check the main function that runs when we start the operator, we await and register the operator. So this is basically this function right here. So this just basically gets the wallet address, registers an operator, and so on the network. And then we then are constantly monitoring for new tasks. So we are looking at the contracts, create new tasks, and when a new task is created, then we do sign and respond to task. We call this function. And what does this function do? It creates a message, hello task name. In our case, this was hello world, and generates a message hash and signs it with a signature with its wallet, and basically calls the contract respond to task. If you remember, our contract looked like this. So this was our respond to task function. And yeah, that's basically it. That's how it works. Oh, and also we have another function called create new task.ts. So what this does, you can open up a new terminal and run make spam tasks, and this will spam the AVS with randomness every 15 seconds. So we are basically acting as, where is my, okay, here, yeah, sorry. So yeah, basically we are acting as an AVS consumer and generating a bunch of tasks. Well, thanks guys for watching. This concludes our tutorial, and hopefully you will have fun with EigenLayer.